So welcome everybody to this union session on international treasures, advancing Earth's environmental and planetary sciences through access, accreditation, and use of natural history samples and collections. I would like to thank you all for joining us at the beginning of what promises to be a really exciting and amazing week of celebrating 100 years of AGU and the sciences it has advanced. I would especially like to thank our panelists who have generously agreed to contribute their expertise to this session, their insights about natural history samples and collections. So let me start by introducing my colleague Lindsay Powers and myself as the co-conveners of this session. Why did we convene this session? Well, physical samples collected in the natural environment have always played a critical role in the earth space and environmental sciences. The studies of these samples and the data derived from them through observations in the field and in the lab have advanced our knowledge and understanding of the earth and universe. From sediments collected on the ocean floor to rocks gathered by astronauts on the moon. From ice cores in the Greenland ice sheet to volcanic gases collected at active craters of volcanoes. From diamonds extracted from volcanic rocks that originated deep in the earth to water samples collected from rivers all over the world. To quote my colleague Dimitri Kourias, who is leading a major European project for a large-scale research infrastructure for natural science collections, samples and collections are a fundamental infrastructure for meeting the most important challenges humans face over the next decades, mapping a sustainable future for ourselves and the natural systems upon which we depend, and for answering fundamental scientific questions. The large investments of public funds that are made to curate huge volumes of samples and to collect and analyze these samples demand that these samples are openly accessible, easily discoverable online, and documented with sufficient information so they can be reused. This is also true for the large volume of samples that are collected and studied by the academic community. But essential infrastructure and policies for the preservation and access of samples are lagging behind to fulfill the requirements of fair samples, of samples that are findable, accessible, interoperable, and reusable, so that they can support integrity and transparency of science as well as future research. This session will focus on aspects of collections management that contribute to the FAIR principles and on efforts responding to national and organizational policies to increase sample visibility and use and tracking, promote recommended practices in sample management, and measure and demonstrate the value of physical samples to science and society. With that, I'd like to introduce our first speaker, who probably is well known to all of you. I'm very proud and honored to introduce Marcia Mcnutt, the president of the US National Academy of Sciences. Marcia Mcnutt is a geophysicist and served as editor-in-chief of the Science family of journals from 2013 to 16. She was director of the US Geological Survey from 2009 to 13. And before joining the USGS, she served as president and chief executive officer of the Monterey Bay Aquarium Research Institute in Moss Landing, California. She was also chair of the Board of Governors for Joint Oceanographic Institutions, which is responsible for operating the International Ocean Discovery Program's vessel JOIDES Resolution. During her time as editor-in-chief of Science, Marcia Mcnutt led initiatives aimed at addressing reproducibility and transparency in science. Among them, a series of 3 workshops that were supported by the Laura and John Arnold Foundation. One of these workshops focused on reproducibility and transparency in the field sciences, drawing attention to the need for open access and preservation of physical samples and collections. I'm honored to welcome Marcia Mcnutt to this union session. She will talk about facilitating sharing and reuse of geological samples, recommendations from the National Academies. Thank you.
Okay, good morning, everyone. It's a pleasure to talk about a topic that's very near and dear to my heart, and that is how we can make science more open and facilitate the sharing of samples for their reuse and also for validating their use in research. So I wanted to start with the outcome of one of these workshops that Kirsten talked about and that she was a co-conspirator in. The result of this workshop was published in Science magazine, and the title of this piece was Liberating Field Science Samples and Data to Promote Reproducibility by Moving Beyond Available upon request, which seemed to be sort of the default mode for many of the geologic samples. And it wasn't just in geology, it was also true for ecology, archaeology, many of the field sciences, where it was the responsibility of the PI to self-curate the samples, and if someone else wanted access to it, they would have to contact the PI and arrange to get access to it. So we felt that the field sciences could be an exemplar for understanding the importance of preserving specimens, because very often these samples were unique either temporally or spatially, and they needed to be preserved for posterity. Because it was easy to see that there might be samples where the sample was collected, and now you couldn't go back and repeat it like you could with a lab experiment, because you couldn't control the situation if you went back. Time had changed, so the climate had changed. Forest succession had changed. Other things had changed. So it wasn't like the lab experiment where you could go back and exactly recreate it. So these samples were unique. And, but many of the sciences were not as advanced at making samples widely available for further analysis. So it was important for extending analyses, for reproducibility, for application of new techniques. We were always coming up with new techniques that you could apply to a sample and get more out of it, which is another reason for making them available, and for testing new hypotheses that might come up. And I show here as a good example of sample curation, the IODP Bremen Core Repository, where they would have the archival sample and the sample that had been widely used for sampling. This is a good example of how scientists knew exactly where the sample had been taken. They knew the metadata was well distributed, et cetera. Good example of archiving samples, and one that had been well funded for many, many decades. So what are some of the recommendations that were being made, first of all, to funders and journals? Well, one of the first in this series of workshops resulted in this paper that was published in Science called Promoting an Open Research Culture. And it said this resulted in something called the top standards, which the top standards were a set of standards for promoting open science standards. And in terms of sample curation, it said we have to promote sample curation and availability from the top down by funder mandates and by journals requiring these standards. And funders could require sample management plans. Many of them do now. Funders could support domain repositories. Many of them do. Many journals now fund standards for sample availability. I think the number is well in excess of 5,000 journals now that actually have these mandates. And often the problem, though, for journals is in monitoring compliance. Journals simply do not have the resources to check when an author has said, yes, I have deposited my samples in a repository, or I've made my samples available, to go and check whether they actually have. So that's the problem. So institutions and societies need to promote not the top-down, but the bottom-up approaches. And principal investigators can lead by example. And when PIs do that, their postdocs and students pick up on that. Universities can offer education in best sample management practices, and societies like the AGU can recognize excellence in sample stewardship in their awards, like, for example, the Ambassador Award that we have here, which could do that, or selection of fellows and leadership. And I'll tell you, we're not doing that here in the AGU in our fellowship recognition. This is my own personal soapbox, that what we recognize in fellowship is too narrow, and it's not recognizing things like good citizenship in archiving and making samples available. And also in our leadership. Who do we recognize in leadership here? And here I give a great example from my former organization, the USGS. It shows an after picture and a former picture in a sample repository, where the former organization, good luck finding a rock in that, and the after, a beautifully organized sample repository where rock samples are kept in neat bins and with good labeling, etc. Now, what we recommended in this science article for our main recommendations were to fund sample repositories, support creation of standard metadata, and assign unique identifiers to samples. And here you see a picture of the IGSNs that can be applied to samples. They're machine readable. You could go in there with your smartphone. You can read those barcodes and immediately understand what is stored there. Create apps that automate the discovery of samples that have been archived. Educate all in the importance of quality control, and change the culture to relinquish ownership while encouraging citation credit. Those two things have to go hand in hand. People aren't going to relinquish ownership of their samples if they don't think they're going to get credit for having collected those samples in the first place when other people publish them. Now, let me go on to the National Academies report. The reason I talked a lot about this science article was because it is highly cited in this National Academies report. And in terms of what the National Academies recommended for samples was influenced by what we published in that science article. Open science aims to ensure the free availability and usability of scholarly publications, the data and samples that result from research, and the methodologies, including code or algorithms, that were used to generate those data. And now I'm just going to focus on what it says about samples. The barriers, high costs. You may need to triage, prioritizing samples that are voucher samples, rare samples, or samples that have been used in the published literature, or difficult to obtain samples. And what we haven't been good at is deciding as a community which ones we're going to put the effort into curating and saving and which ones we aren't. There's a lack of infrastructure, including repositories, standard metadata, and support for curation professionals, professionals who know how to do this well. As you all know, it's really hard to support a technician in the curation of samples. Lack of supportive culture, incentives, training, and need to address the criteria for advancement and how credit's assigned. There's also issues of privacy, security, and proprietary barriers to sharing. There may be some samples that are so rare, you don't actually want to let people know where you collected it because you're worried about people going out and raiding those sites and therefore destroying them. So recommendations. Change the culture to reward and support the behaviors that promote sample curation, preservation, and sharing. Institutions and society should train students and professionals in open science practices, ensure the long-term preservation of priority samples and procedures for deciding what deserves preservation, and facilitate discovery and sharing using fair standards. So very similar to what came out in that science paper. So, and here are just the benefits which I'll leave you with: rigor and reliability, ability to address new questions, broader participation in research, effective use of resources, and improved trust in science through transparency and openness. So thank you very much, and I'm happy to take a few questions if there are any. No questions.
No questions for now. We definitely have we will spend the last half hour or so of this session for open discussion with the panelists, and I hope that you will come up and ask or make your comments. You know, you can provide your insights and trigger some discussion that way as well. Okay, so we're then moving on to our second presentation, which is great to have Leslie Wyburn here. Leslie Wyburn is an adjunct fellow at the National Computational Infrastructure in Australia and the Research School of Earth Sciences at the Australian National University. She also works part-time for the Australian Research Data Commons. Leslie Wyburn's career began before the age of computers and the internet, and she has over 50 years of experience in collecting and chemically analyzing rocks. But she also focuses a lot on the management of geoscientific data. In geoinformatics, her main interests are developing international standards that support the integration of earth science data sets into transdisciplinary research projects, and in developing seamless high-performance data sets that can be used in high-performance computing and cloud environments. She's currently chair of the Australian Academy of Sciences Data in Science Committee and is on the AGU's Data Management Board. Leslie is engaged in multiple initiatives and projects to enhance the integration of physical samples and collections in the digital research data ecosystem, such as the International Identifier System, IGSN, and the Interest Group for Physical Samples in the Research Data Alliance. Leslie will now tell us why our treasures need no longer be buried, advancing physical samples from personal items to globally shared first-class objects of international research.
Thank you, Kirsten. So this is my paper with Kirsten and Jens Klump. It has a very Australian flavour to it, as you will see, but I'm just reflecting on a career of over 50 years of collecting rocks and preserving data on them and asking a few questions. Recently, I was very privileged to be part of a meeting in China with CODATA, where we developed the Beijing Declaration of Research Data. And the key thing we were able to get into that was that the definition of data is data sensu stricto, but also the ecosystem of digital things that relate to data, as well as physical samples, analogue artefacts, and the digital representations and metadata relating to these things. So, you know, physical samples take up half of that definition. But finally, we have an official recognition that data samples are first-class citizens of the research ecosystem. I call that a victory. Victory number 2 is this wonderful thing that came out in Australia called the Responsible Conduct of the Code of Research in 2018. And it's signed off by the Australian Research Council, which is equivalent to NSF, National Health and Medical Research Council, and Universities Australia, which comprises all the Vice-Chancellors of every university, and they actually signed this. And they have 8 principles, and I thank Marcia for her talk, because number 3 is transparency. In that, a researcher, the principle is, will share methodology, data and findings openly, responsibly and accurately. Now, to support these principles, they then developed these responsibilities. And so institutions copped 13 of them. And number 8 is that they will, institutions, provide facilities for the safe and secure storage and management of the primary materials and allow access and reference. The poor researchers cop 16 responsibilities, but number 22 says that researchers will retain primary materials and allow access and reference to these interested parties. Things are looking good. And thank you, Marcia, for taking people through, and we now know that we have the IGSN place, where if you publish a paper, you can reference the unique identifier for the sample that supports your paper, go to a landing page for that particular sample, or then connect through using linked data to other samples that are in that collection. Hooray, we're getting there, but what is the reality? Please note, no person who contributed an image wishes to be acknowledged. And this is a collection of photos from a few universities that show you the state, despite all those wonderful things I said at the start, of where we're at. And I love one major university, who shall remain nameless, who actually has these containers out in a block in an industrial area about 15 kilometres from the university. And I hope they're not analysing those samples for lead, because you can see the paint peeling off the ceiling in the second photo on the left. Oh dear. Now, this is not a problem that's common to universities. Just carrying on. And so I just want to give you my personal story. So this was my PhD area. We call them Alps, and I think you'd laugh at them because they're only about 2,000 metres high. But if you wonder why I've got crooked knees, it's running up and down those hills. And in particular, there is a tunnel that goes through that mountain where I collected many samples. And you ask where those samples are now, even though they were catalogued. They're in Professor Gordon Lister's garden path. Now, I can't exactly say they're buried, because you can still see the tops of them, but he didn't expose the numbers. They wrecked his path. But you can see how, even with the best intention, this is what has happened. And industry doesn't make life much better. And unfortunately, this is what happens at the end of a drilling program. Thank you, Tim, for allowing your name to be on this. But the currency is that the core trays are more valuable than the actual core themselves. And you can see how the sheds have been stripped of all the core trays because they're being recycled elsewhere. But look at that incredible asset. And it's gone. As we said, we have the IGSN number. There's no reason. We can provide that unique identification of our samples and connect through to the publications, etc. So now we're not just tracking numbers of people who come to a museum and visit it. We're actually tracking the usage of that sample in the literature. And because we can connect to the papers, we can actually see whether or not it's used in a high impact paper. What was the value of that sample to the overall corpus of scientific research? So where do we go now? We're starting to also look in Australia at some techniques which we're calling digitisation of the samples. Not just photographing them, but starting to use mineral techniques like hyperspectral imaging to see if we can reduce the amount of data or volume and make them more accessible. But we do not always succeed. Maybe we started too big. So this is a collection of 300,000 heavy mineral concentrates from all around Australia. I'm not too sure if it's still around. We were trying to rescue it. But the estimate for rescuing this proposal, even though part of it did include digitisation and making it online to try and increase its value, was 9.5 million, and we don't think we really succeeded. So we started a bit smaller, and when Professor Neil Mcnutt retired from the University of WA, he donated his shrimp mounts, everything, his samples. They were actually about to be thrown out. And so Ozscope came in, which equivalent to EarthCube, and we started to say, what can we do as an experiment to make this data set available, but make it more available online. And so, as I said, in the top left, you have the samples that were about to be ditched. They were loaded up, taken away, scanned, using the techniques. We've got the photos, and we're putting them together as an online resource. This is just an experiment and as a proof of concept to see if it works. This is kind of what we say about a digitisation of a collection. That is, we're not just taking photographs of the samples, we're actually adding scientific value to what we have. Again, going back to the drill core, so that photo that Tim lent me showing the pile of drill core led to another project where we have these hyperspectral scanners of the logs. And you can see here on the left, this is all the cores that have been scanned and are available online. This is the logger itself, and the most difficult thing is the labour to lift those core trays up and down and onto the machine in order to do the scanning. In the top right, we have a result of one of these scans, and you can see the accuracy and quality of the photographs. It's scanned at 8 millimetres, but it doesn't just create a photograph, it creates a hyperspectral image so that we start to get a mineralogical pattern of what is in that. But yet again, I'm now going to put on my data hat and say, here we go again. The data is too detailed for web delivery. The geological surveys cannot store the data at this volume. They cannot make it available online. And so these accurate 8 millimetre slots are binned into 30 to 40 centimetre intervals and made available. But yet that raw data, which the data of tomorrow will be able to go through and produce very, very easily, is not accessible, and I am concerned in some areas that we may also lose not just the core, but also these detailed scans that were meant to be an alternative measure of preservation. So the path forward, if I look at this and I listen to Marcia, we have so many building blocks in place, the ability to uniquely identify the samples, the requirement for them to be cited and preserved, but the funding for the repositories and the curators of those repositories. I remember when I started at university, we had a full-time curator. Name me a geological department in Australia that has a full-time curator. I can't. We have commitment in theory, but not in practice. We cannot save everything, and Marcia said all the policies about trying to work out what we should and what we should not save. And based on these experiments with the virtual core library and a few other things, can we do more with the digital representation of samples so that we get the full mineralogical spectra of the data, but just keep a few representative samples? All I'm arguing is whatever we're going to do, we need to act now. We, particularly me, no longer have the gift of time. And I hope that our treasures will no longer be buried in people's garden paths.
Questions? Anything in between before? Think about it. I think we need to move to the other computer. Yes, absolutely.
We understand. We are pretty much the choir, the converted, we all know. Is it only a matter of money or also a matter of us communicating properly the value of samples? I mean, I hear in the data world the approach that people have that if we have images, it's enough. They don't understand that there are chemical things, at least it's not obvious that there are chemical things you cannot do with an image. So maybe it's a problem of communication, that we don't know how to express this properly.
want to repeat the question for people on the line.
Oh. The question is basically, in a very short, condensed version, are the problems that we're facing right now just a matter of lack of funding, or are they deeper embedded in the problems of not communicating the value of samples and the cultural issues? Any one of you?
So, Esther, I would say it's a combination of both of them, because we have come a long way in terms of archiving digital data, because it's frankly pretty cheap. We're just saving bits and bytes, and you can add more servers and at a pretty low rate and save them. But I think the problem with samples is, first of all, their heterogeneity. They cannot all be reduced to just bits and bytes, and so there's a much larger problem in heterogeneity, particularly when you go to biological specimens, and many of them have to be kept in freezers at minus 40 degrees C or something like that, or sometimes many of them have to be preserved in special ways. And so there's so much heterogeneity in physical samples that prevents a one-size-fits-all solution to them the way it is with bits and bytes. But I agree with you that what I really liked about the idea of some pilot projects was basically showing the value of them, and that's what I think we don't do enough of, is having some preservation programs with some samples and making sure that it's not just samples go into the repository, but then samples are reused, and we actually celebrate the successes of the reuse of those samples when we actually make the metadata, the availability of the samples, and the integration of samples across many repositories, and show that, that value to a high degree, and that's what we're not doing enough of.
Thanks for the good question and response. Next, I'd like to introduce Jennifer Bucca Maroa. She works under the programmatic arm of the African Academy of Sciences in Nairobi, Kenya, that focuses on improving the research and development landscape on the African continent. She's responsible for the management of the Human Heredity and Health in Africa program and the development of an open database for African clinical trials, capabilities, and sites. Jennifer is leading the African Academy's effort to develop the continent's first cross-disciplinary guidelines for collecting, sorting, and sharing data and specimens. She's currently a clinical associate professor at the University of Washington in Seattle and a 2018 Aspen New Voices Fellow. I would highly recommend looking up her presentation online. We're excited that Jennifer is able to join the panel of this session, and she's going to speak to us about managing African research data from ownership to custodianship.
So thank you very much, Lindsay, for such an introduction. I'm humbled to be here. Thank you so much for inviting me. Lindsay got to know about, the committee that I set up from a Nature paper, article that was published way back in June when we had this meeting. So I must let the audience know that I'm not from the geophysics world. I am a biomedical scientist. So the story that I'm going to tell you today is in relation to biomedical sciences. But again, the issues that they are raising here are very similar with what we deal with. So I work for the African Academy of Sciences, as you've been told. I'll tell you a little bit about the Academy so that you can see where we are coming from and where we are going. We are a Pan-African and non-political organization. We are based in Nairobi in Kenya, but we have offices in 5 other countries to represent the 5 regions of the continent. We work very closely with the African Union, which is the one that it really takes care of the developmental challenges of the African continent, specifically the African Union Development Agency arm. We have three main issues that we are really focusing on in our strategic plan 2018-2022, which is excellence, partnerships, and people. In excellence, we want to make sure that we are funding and looking for excellent people who are doing excellent programs in excellent places so that we can actually be able to answer relevant questions for the continent. We are looking for partnerships, and you will see in my talk that we have been very heavily on the health side, so we want to expand and do more in other areas, including what we are talking about here today. And then we want to make sure that the people that we work with are enabled by creating good environments for them to learn and grow. So these are the three mandates for the Academy. We recognize excellence. We are an advisory tank for the African Union, and we implement key science, technology, and innovation programs on the continent, and that's the arm under which I work. And these programs are focused at enabling the continent achieve the Sustainable Development Goals at the end of it all. And so these are our strategic focus areas, and you can see health and well-being is really what we've been focused on a lot, and we do recognize that we need to expand into these other areas. We've more recently started funding a lot of work in environment and climate change, but the social sciences, the natural sciences as it is, we haven't been doing very well, I must acknowledge, so we would be happy to speak to people from this group so that we can expand our partnerships. And now moving into data. So as you probably know, the African continent bears the greatest burden of disease at 25%. But our output in terms of research, if you Google that, it's about 2%. But that doesn't necessarily mean that research doesn't happen on the African continent. Indeed, there's a lot of biomedical research that happens on the continent. The question becomes what happens along the way. So this paper, which was published about 2 weeks ago, actually makes my introduction here very easy, because in this paper, the authors looked to see papers that have been published between 1980 and 2016 in the area of HIV, malaria, Ebola, and one more, TB. And out of the 1,000 papers that they pulled out that met their criteria, 93% of them had an African-based author. But unfortunately, only about 50% of them were the first author in those papers, and then only about 41% of them were a last author. We've heard one of the speakers here talk about people being recognized for the data that they contribute, or whatever input that they have in whichever work. So this kind of tells you what has been happening on the continent over the years, where we have our partners from whether the UK, Australia, the United States fly into the African continent, use the local expertise to form their study participants, enroll participants, collect the samples, sometimes actually fly back with the samples, generate the data abroad, and then publish without even mentioning the participation of the African and local expertise. And so this has, in a long time, not been in the open, but now people are beginning to speak about it. As you can see, there's this paper that was published, and actually 2 papers came out at the same time. The other one, they're talking about the African scientists being stuck in the middle, not in as first authors, neither as the last authors. So we do have biomedical research happening on the continent. We give out a lot of biosamples and data, but the question is, does the benefit ever go back to the people that actually participate in this sample collection? So here is the new norm. The new norm, we are moving to open data, and everything is becoming open. And African scientists actually do want to share their data. They want it to be open. The question becomes, the playground is not the same. We have a lot of barriers, and I won't get into them. Marcia has already talked about them, very similar barriers. But beyond those barriers, there are others that are very, very relevant to the African continent that are probably not a challenge in Boston or California, for example. So one of the leaders of our bioinformatics team, Nikki Mulder, who is based at the University of Cape Town, one of the best institutions on the African continent, was telling us about the challenges they have with handling genomics and genetics data. Our data set is about 7 to 20 terabytes. They'll need about 20. This takes about a second to copy 25 megabytes, taking about 7 days. Encrypting it takes about 7 days. It's already taken them 2 weeks to do just that simple process, which I think in Boston or here or in Seattle, it's not going to take someone to do 14 days to do just that simple process. So the question then becomes, when our funders put the regulations that you need to put your data out in the open immediately, is that being fair? Is it equitable for the African continent and the African scientists? So how can we make it better so that we are still able to share the data, but the African scientists are still able to manage that data, mine their data, and also do capacity building along the side for the development issues for the continent. So with that in mind, then we formed this Data and Biogovernance Committee. As you can see, it's very broad, expertise in there representing the continent. And the aims were basically, I won't read all that, but in a nutshell, we were trying to look at the opportunities and challenges of data and biospecimen collection, but while considering the communities that participate in this, the ethics around this, and benefit sharing back to the communities that actually participate in this biomedical research studies. So we had our first inaugural meeting in June of this year. We themed it governance and utilization of African data for development. There were 5 key things that we looked at: community engagement and participation, the ethics and informed consent, data governance and access, benefit sharing, translation, innovation, and intellectual property. So I have that scale over there because what the bioethicists believe happens is that even when we have best practices that are internationally recognized, when our partners fly into the continent, they do less of what is right and more of what is wrong, because it's a space that is looked at as an ethics-free area. So, you can go in and do whatever you want. And in part, it's one of the things that we want to get at. How do we harmonize activities across the continent so that people don't feel like if Kenya doesn't have very good guidelines, I can go there and do whatever I want, but I can't do the same thing in South Africa because South Africa is much more developed and has better guidelines. So, getting into each one of those key domains, then, what is community engagement? What does that really mean? I mean, somebody here has already talked about the communication part of it, right from the people that actually participate in these studies. We want to make sure that they understand and know the value of research, the value of data sharing, and what the different models in data sharing, and what it actually means to participate as an individual versus to participate as a community. And then what is the role of institutions? And institutions need to do capacity building, but also to engage with community leaders who sometimes are the ones who actually make the decisions on whether communities participate in research or not. In terms of ethics of informed consent, what is informed consent? What does that actually mean if you're talking to people who are illiterate and cannot read in English? What does that mean? How many times do you have to talk to them to be comfortable that they can now actually sign a consent form and they're actually involved? For example, if you're talking about genomics and genetics, how does that translate to local people? What is the role of the funders in promoting equity? Do African scientists feel comfortable enough to negotiate at the table or when they're signing these grants? And how do we then also make sure that when we collect this data and publish it, we publish the results in a responsible way? Because sometimes some of the findings might impact huge communities in huge ways. So we need to understand the local context better as we deal with that data. So we spent a lot of time looking at data governance and access. And as I've alluded to, Africa is 54 different countries. They look at things in different ways. The cultural issues are different. But can we harmonize a lot of this work so that even for our partners and funders, we make it easier for them? Because we'll have one policy or one guideline that we can look at as a continent, and then we have maybe 25% of it that allows for the different nations to put in what is different about their countries. How do we then also use the fourth industrial revolution, for example? Can we use blockchain technology, for example, to code our samples and make sure we can track them and know who is using the samples or who is using the data, and how does that, if there's commercialization out of those samples, how do the benefits then track back to the local communities? And then we also talked about benefit sharing. What constitutes benefit sharing? Different communities will expect different things, but we know that biomedical science, for example, it takes 15, 20 years before you actually have a product. So in the meantime, what do you do? What do you give back to that community? So again, can we have guidelines and policies that are continental, regional, and at national levels that are acceptable? Can we have the scientists and government have a strong negotiating position when they're talking to their funders and different partners? Can ethics and regulatory bodies probably make this part of a requirement whenever it's possible? And can we have legal frameworks that are, speak to some of these things? For example, the Nagoya Protocol doesn't necessarily talk about human samples, but can we have human samples included there? So those are questions that we are asking ourselves and wondering how to move forward with them. And finally, of all the data that is collected from the African continent and analyzed elsewhere and published, very little of it actually goes, back to benefit the continent, because we don't have innovation pipelines on the continents that are efficient. We actually don't have much. If there's anything, it's probably going to be in Egypt or in South Africa. So how then do we localize the value chains, making use of the data that is relevant to the continent and pushing it down the innovation pipeline right on the continent to make the products more accessible and affordable eventually? Because when the data goes out and the products are generated outside, bringing those products back into the continent becomes impossible, and therefore the communities actually who participated in these research studies don't benefit at all. And so this is one of the things we concentrated on, looking at how to encourage African governments also to invest in innovation so we can identify the relevant questions, find the right technology, look at the correct business model, and use the proper systems to promote innovation on the continent for the sake of the people. So in summary, there are some key action items that we need to be working on, looking at educating and empowering research participants, encouraging locally relevant consent processes, exploring technologies to track samples, developing Pan-African data and biospecimen governance to inform local and international partners, providing guidelines and policy to better negotiate for benefit sharing, and providing guidelines for the intellectual property translation and innovation agreements for African localization and translation of value chains. The meeting actually came up with a paper that we are in the final stages of developing, and when that is out, I'll share it with Lindsay if anybody needs to take a look. It's a very long paper, so this is an injustice I've done trying to summarize it in 15 minutes. But these are the partners that we work with at the African Academy of Sciences. Thank you very much for listening to me, and I'm happy to take questions either now or later. Thank you very much.
Huh.
Are we missing a presentation?
We might be missing a presentation, so I'm just going to, let's go to Carol.
But I've seen it.
I'm going to go check. having a little technical difficulty. So I think we're going to go ahead with Carol Butler. Carol is part of the science leadership team at the National Museum of Natural History Smithsonian Institution, with responsibility for the museum's collections and collections-related central services. She oversees the biorepository and conservation, digitization, and registration functions, as well as the roving team of collections program technicians. Carol leads the development of collections policies, plans, and funding requests, as well as the museum's Collections Committee, Genetic Resources Oversight Committee, and the Digitization Committee. She serves as the Smithsonian's Collections Advisory Committee and the Collections Space Advisory Committee. She's led numerous workshops and training programs reaching museums, students, and professionals from the U.S., Latin and South America, Europe, India, Pakistan, and Oman. She does it all. And we are very pleased to have Carol here to talk to us about promoting collections, relevance, and use at NMNH. Just use the arrows.
Good morning. Thank you, Lindsay and organizers. As you heard from that introduction, I'm not a geologist. I don't play one on TV, but I will do my best to represent the activities of the National Museum of Natural History. As Lindsay said, I lead the collection stewardship work of the Smithsonian's National Museum of Natural History, covering all of its anthropological, biological, geological, and archival collections. Today, I'm focusing on the geosciences collections from the Department of Mineral Sciences, some of which are shown here. The theme of this conference, to celebrate the past and inspire the future, is right in line with the Smithsonian's intentions. We make significant investments in the preservation of the collections. Some people say we are in the forever business because we serve as a public trust for the nation's collections. That responsibility is complemented with the responsibility to provide access and to promote its partner, usage. Our intentions regarding preservation, access, and use take both a physical and digital form. I'm going to talk about the digital accessibility and usage indications of the collections, and then put that in the context of FAIR principles. Increasingly, I find these principles to be a clear and helpful way of organizing and prioritizing work. And more on FAIR in a moment. Who are our users? Our audiences are, as you might expect. Now, with our new secretary's goal of reaching 1 billion people, we are intensifying actions to make the collections accessible and usable, not just in Washington, but everywhere. Digital access to information has been opened by default via our website and various aggregators, although our policies allow the restriction of some kinds of sensitive data, such as specific localities for threatened and endangered species, localities of fossil and cultural sites, and some collector names, among others. Here's our status on digital records. In the best of all worlds, each of the Natural History Museum's 146.3 million specimens, objects, items, samples would have its own catalog record. I think you'll agree that that result isn't likely in the near term. So we set a goal of creating about 48.5 million records to represent the museum's entire collection. We are at 9.8 million records towards that goal. The picture for geoscience collections is better. For the 1 million plus items, we have completed 381,000 of the intended 484,000 records, or 78%. And that's a number that makes my heart very glad. And how do we organize the work to make that kind of progress? Some years ago, the museum asked 2 fundamental questions about its collections. Do we have the right collections to meet our mission? Are they the appropriate collections? And are they ready to use to meet that mission? We developed an assessment schema to help us answer that question, and I'm happy to say that on question 1, regarding appropriateness, we could say a resounding yes. We have the appropriate collections to meet our mission, although we did identify some gaps that we would like to fill to make sure the collections are as comprehensive as we intend them to be to serve as the national collections. But on the second question of readiness, we realized we had some work to do. Our initial assessment clearly showed that, as you might expect for an institution that is more than 150 years old, we had made far more progress in the physical care of our collections. Partly that's because of the collections were born in a pre-digital age, many of them. So our relative strengths of physical care were greater than our strengths in digital care, informational care. And the graph you see here shows how we used our assessment methodology to help us prioritize work. That methodology compares criteria related to importance versus physical status and importance versus informational status. We defined the collections, in this case in the Department of Mineral Sciences, into specific groups that could be ranked on a 5-point scale, and the scores then plotted. Informational status on the horizontal axis relative to importance on the vertical axis, with 1 being poor or low and 5 being high or optimal. And you see a clustering, it's hard to see, the lights in this room don't help me, but there is a clustering of dots that represent collections in a sort of virtuous upper right-hand quadrant that shows those collections meet our acceptance criteria for basic collection stewardship. And in this graph, you see it highlights collections including the mineralogy reference and micromounts, the National Gem Collection, petrology historical reference collections, and others. Now, complementing that virtuous right-hand upper corner is the left-hand upper corner, which is the target of opportunity section. Collections that score in this quadrant are important, but not in the best shape in terms of their information. And the collection that you see here is the backlog. Not surprising, but clearly a target of opportunity for creating improved collections records. The collections that score in the lower half of the graph requires additional review. And that's because a criterion of usage contributes to the measure of importance. And lack of usage does not necessarily equal lack of importance. That's an element of work I think the museum needs to revisit in this assessment methodology, because I have the feeling in my gut that if we promote the use of those collections that have scored lower, perhaps because their importance score is low, we'll see them make a greater impact in science, make a greater impact, and be more relevant to our audiences. Let's turn to those FAIR principles. The geosciences collections traditionally have been findable through research communities and via the museum's website. I'm pleased to say that many items have now gained a persistent identifier in the form of EZIDs and IGSNs, so the findability of these samples is enhanced and not reliant only upon professional networks. We have baselines for findability and accessibility in traditional museum metrics in the form of loans, citations, and research and web visits. I expect as more samples have those persistent identifiers that are used, will recognize citations more easily and be more accurate and complete in tracking use. There will be a positive feedback loop for researchers accessing the collections. What about the I and the R? We've made progress in the museum with the F and the A, but I and R are more challenging, and my colleagues tell me that this is a very difficult nut to crack. I think geosciences collections need the attention that our recent biology collections have received. Museum staff are working with global communities on the EFG extension to the ABCD Darwin Core for geoscience records. And I think having a geo equivalent to the Darwin Core would be a great step forward and would make a much more powerful aggregator for this part of generalized science. The Smithsonian is launching an open access initiative in February across the entire Smithsonian collection, so art, history, culture, and science, and will be posting more than 3 million records, predominantly from our museum, as part of this open science initiative. So that helps with getting towards interoperability and reusability. But clearly, the museum has a lot of work to do in this area. Our challenges are in development, standards, consistency, and participation. I've already mentioned the EFG extension and the promise that it holds. Data managers at the museum have also looked at historic metadata and found many challenges when grafting existing vocabularies onto that data. Problems were in the lack of widely used vocabularies, ambiguities in use, archaic terms, and other limitations. Within the museum work of assigning and using persistent IDs, we need to make sure that's prioritized and part of our regular workflow, carried forward as a standard practice, and promulgated when working with students and other research communities. We need to participate in best practices for management, and we need to consistently promote best practices. As we can, we need to use existing tools to mine for data, tools such as GeoDeep Dive, and employ any new tools that are developed so that we can link historic data with existing collection records. Just as the museum has pivoted to digital care after its strength of physical care, I'd like to see the museum pivot to more interoperable and more reusable ways of managing data, not just findable and accessible. In closing, I'd like to acknowledge the work of my colleagues in the Department of Mineral Sciences in their stewardship of the collections, and thank Adam Mansour and Rebecca Snyder for their assistance with this presentation. Thank you.
Are there any direct questions for Carol? Maybe we have our technical problems solved. Somebody is out of breath. Let's see. It wasn't here. He says it's there. So weird.
He says on the server, it shows up here, but I don't see it. Do you have a printed copy, or?
I have a copy on it. Does that help?
I don't think we can add anything.
This is so weird. I thought I saw it earlier as well.
It's not on the desktop, is it? Sorry for the technical difficulty. They are separated, but yours is supposed to be on here.
There it is.
Oh, there it is.
Yes. Why did it? You know what? It was a PDF.
Okay. Maybe because it's a PDF.
It was a PDF.
PDF, yeah.
It's possible that was the problem.
Okay. Problem solved, we hope. Mark Weimer is the Assistant Director at the USGS Patuxent Wildlife Research Center, and his research focus is on wildlife management and conservation in North America. Mark's responsibilities there include having supported a small team of USGS researchers and curatorial staff working in the national vertebrate collections at the Smithsonian National Museum of Natural History. Through that role, and because of his previous experience reorganizing tens of thousands of bird specimens in archival trays for $7 an hour when he was fresh out of college, he's a member of the USGS Collections Steering Committee, and he was the co-chair on the working group to develop the collections policy he's speaking about today. So today he'll be talking about scientific working collections, a case study in the new USGS collections policy. Thanks, Mark.
Thanks. I think we've seen some horror stories about collections that are poorly cared for, and we've heard some very high standards. So this was a chance, a policy on, how do I go full view here? This was a chance to set up a policy for an agency that contains a bunch of scientists that work with, some of them with collections, and try and implement some of these. USGS has its own code. It's a survey manual, we call it, which is our rule book, essentially. And last summer, the Collection Steering Committee released a policy, a draft policy, a draft chapter in that manual on how to care for and plan for scientific collections. And one can reasonably ask, why have we not had a policy previously? We are 140 years old. Well, the need, I would argue the need emerged relatively recently. We've been doing PI-driven science, and as individual researchers largely, we don't necessarily see an obvious need as individuals for a policy. But things have changed. Scientists clearly do, in some cases, in USGS, maintain scientific collections beyond a single collection-based study, sometimes multiple, sometimes for longer. And adding to the complexity of our work, there was a relatively recent diversification of the USGS mission in the 1990s when we absorbed people, research functions, and collections from other DOI bureaus. And then adding a little urgency, there's this wave of anticipated retirements of people leaving collections, sometimes poorly documented, and that's been discussed in numerous places. So we released this policy in the summer. It's a draft policy, and that's because we don't know what we're doing. And we have an idea of how to maintain collections and what the documentation standards should be, but we don't know how many collections we have. And so this is a chance for us to get it right and to not chase people off from adhering to some best practices. We've developed everything from templates to guidance to go along with this. I don't know if you can't really read the fine print here, but in 1879, the Sundry Civil Act said that when USGS was done with their research, they could deposit their collections in the National Museum. I think the technical language is drop it off at ye olde loading dock at the Smithsonian. Needless to say, a lot's changed since then. It's not that simple. I know Carol can't take on everything. All right, so the elements of the policy are that really USGS does have primarily working collections. And by that I mean collections that we don't necessarily set out to keep. And that's because we are planning a research program or a research investigation that's a fairly short cycle. But we still need to require working collections to have a plan for both acquisition, for storage, documentation, and disposition. And we need to make sure that people know their responsibilities. And while this might sound boring, we think one of the big reasons that we can't advance into some of these principles is people really just don't know what to do. what kinds of collections does USGS keep? And if you're someone who's used our core sample collection or our coral research collection, or maybe some of the biological or geochemical samples at our Woods Hole Institution, you know about some of our collections. They're well documented and they have collection staff. But an initial survey we did several years ago when we were laying the groundwork for this policy showed that we've got maybe 200 or 300 other collections, at least at that time, that had persisted beyond the initial studies that they were conducted for. But we don't really know the condition of those. Biologists might be taking feather, skin, or blood samples. We might have waterfowl cultures taken for avian influenza monitoring. We have botanical and vertebrate collections, by the way, and some of those represent our only cases of accession to museum property in USGS. So I mentioned that we took on some programs from other bureaus, including these biological collections, and that did add to the complexity. So we knew after that survey that we weren't tracking them properly, and to ever get a handle on the ideal situation of sharing, we would need to do better. And so our policy focused on that. This is perhaps overly complicated, but think about a scientific study. There's a work plan, right? There's a budget. You propose your questions, your analytical methods. You subject it to peer review before you start. And USGS requires this. That survey manual I mentioned earlier, our workbook, this requires it. So we had a good place for us to nest our policy. And what you see on the far right of this diagram is things happen when our samples are not completely used up in the course of a study. Maybe they're deposited into an existing repository as voucher specimens. Sometimes they're consumed. But looking backwards, we found that we do have some of what might be termed legacy collections. They're retained. And we don't have that documentation. And so our goal here was to simply try to integrate it into the planning process. In many ways, integrating it into the planning, in other words, a research cycle, does two things. It helps us properly resource collections-based work, but it also makes sure it's relevant. Carol, in the survey of the collections at the Smithsonian, mentioned that. Do we have the right collections? And of course, a working collection doesn't have a scope of collection statement like a museum collection might, but a collection plan is an equivalent and a much smaller scale. One can see the idea of an open data, an open sharing plan for a collection similar to an open data policy. And it's similar to USGS's, and we patterned some of ours after it. Well, one of the things that happened after we released our open data policy was that scientists asked, even though they could simply release a data set relatively easily after the publication was done, some of them asked, why should I focus on helping others use the data I've collected when I can get more work done, I can get another publication out? And that's a natural response. It's a different perspective. So some of the risks and challenges, some of the things we dealt with, Esther asked what the barriers are, and I think some of them are cultural or, what you're used to, how easy it is maybe. Maybe the tools, taking on what interoperability means is not a trivial topic for someone who's laser focused on something else. So that's what we thought about as we said about this policy. Can we make it easier? I don't think we're there yet, which is why it's a draft, but we've started. But, someone who wants to use those collections, who maybe learns that they exist and doesn't have access or can't see the data, might grow pretty indignant about that. What do you mean these federal assets aren't well cared for? Well, remembering that Congress doesn't fund USGS to create and curate collections has to play into it. About a decade ago, the Interagency Working Group on Scientific Collections produced something called the Green Report, and that and other sources say federal collections are somewhat in peril, right? So now we have to worry about it. Are we going to cause the creation of collections that we can't maintain? So those are part of the sort of the background, and the risks. But we also know we need to do better, and that there will be a positive feedback loop if we do it right. And so here are some elements of the the findability and the accessibility. We're starting with a metadata catalog. We're using what we call the National Digital Catalog, which is embedded in USGS's science base, or directly using the global repository called GR-SciCall. These can be harvested. Some of our better-known research collections are already in there. Elements of the metadata itself can help with accessibility. Interoperability is probably our biggest barrier. Having a shared vocabulary or knowledge representation of specimens and samples across many disciplines that USGS researches is a challenge. But we do plan to adopt unique identifiers, encourage following community-based practices, and our collection steering committee will practice those and store those and promulgate them. We have something called BISON in USGS, which is a biological observation system, which really meets most of the principles, and findability and even reusability. The challenge with that is it's a narrow set of fields. It's not very rich, but it's a great start and it's a good model. And a practical policy is really going to have to benefit USGS scientists. And so these are some of the things that we think about. If it helps us reuse our own material or creates more potential for collaboration, we think it can succeed. We think if we develop tools that are easy to use or easier to use, peer pressure will kick in at some point as well. And as policy and compliance can mature and provide those tools, we'll better document our collections use and the resources needed for it, because we all know that collections that do get used, that use is underreported, and that's a negative feedback loop, and we need to reverse that. Thank you.
Are there any questions for Mark? Okay, our final speaker of the session is Eileen Graham. David Shindell, the first author, was unable to join us today, but Eileen has kindly volunteered to present the work that she has been involved with. Eileen is currently the partnerships manager at the Smithsonian Institution, and she's responsible for establishing and expanding partnerships for visiting researchers, fellows, and interns through program development and strategic partnerships. She was previously the program manager for Scientific Collections International, SciCall, as it's known, an international initiative headquartered at the Smithsonian. She managed the development of a global registry of scientific collections, which is an online registry of institutions and the scientific collections they hold as part of SciCall's objective to improve access to information about collections. She also represents SciCall to the U.S. Interagency Working Group for Scientific Collections. And in her past, prior to joining the Smithsonian, she managed samples and data collected across numerous academic institutions and disciplines on behalf of NOAA as part of the ecological impact assessment at the Deepwater Horizon oil spill. Her background is in marine science, including marine ecology and physical, biological, estuarine dynamics. So, welcome, Eileen.
All right, good morning, everyone. As Lindsay mentioned, I'm from the Smithsonian Institution, which is one of the agency members of the Interagency Working Group for Scientific Collections, which has been mentioned once or twice already today. I am pleased to share with you some of the work that was conducted by our colleagues in that group. As Lindsay mentioned, David Shindell is the lead for this study on economics of collections. I will present what I know about the report, and I will include his email at the end. I will do what I can. All right, so before we get too far into this, one thing that I do need to note is that the full report on the economics of scientific collections is still under review by a number of our agency partners in our working group and the National Science and Technology Council. So as a result, we'll only be able to share a couple of things. But the report itself will present a framework of the services that institutional collections provide, the operating costs they incur, and the policies and practices for cost recovery, such as user fees. So when we submitted this abstract, we really believed that the full report would be available. Unfortunately, I won't be able to share kind of the really good stuff, the findings and recommendations, but that's okay. All right, so I will start by going through some of the background on our interagency group and a preview of the methods for documenting the costs and benefits. Lindsay, one of our hosts here, has been integral in the writing of this report, and I'll be able to actually talk about some of the methods and data contributed by her agency. So we do hope the report will be available, honestly, in the next couple of weeks, so the timing is just that unfortunate. Lindsay will be one of the first to receive it and hopefully can pass along to those folks that are interested. Okay, so a little bit about the Interagency Working Group on Scientific Collections, affectionately called IWGSC. So it was created in 2005 as an activity under the Committee on Science of the National Science and Technology Council. The NSTC is part of the Office of Science and Technology Policy, which is nested under the Executive Office of the President. So at that time, and we still use this today, the truly interdisciplinary group touts the scope of our collections as being from microbes to moon rocks. IWGSC has about 15 participating agencies, including several sub-agencies in our membership, those that operate or otherwise provide federal support to scientific collections. Several of those you've heard from today, so including the Smithsonian and our Natural History Museum, the U.S. Geological Survey, and their other Department of Interior sub-agencies, including Bureau of Land Management, National Park Service, and then additional agencies that will focus on human health, agriculture, and national defense, among a couple others. The early years of IWGSC focused on two major initiatives. First was a government-wide survey of object-based collections owned and operated by the federal government. So it's hard to believe now, just about a decade after that, that the survey itself was the first of its kind. It unearthed a variety of collections that had previously not been part of the general understanding of the scope of federal collections. What that survey found was that the scope was vast and varied, and not surprisingly, continuously growing. So the second major initiative of the early years of IWGSC was a report that included results from that survey and highlighted many rediscovered collections. Published in 2009, that report was formally called Scientific Collections, Mission Critical Infrastructure for Federal Science Agencies, commonly known as the Green Report. as depicted here, yes. The Green Report included a number of recommendations to federal agencies that held or otherwise supported scientific collections. One of those recommendations was for the development of policies to govern those collections. And IWGSC worked hard for several years, sharing policies from agencies that had already developed them and supporting other member agencies in the construct of their new policies. The result of that effort of all of the agency policies are now accessible through the IWGSC website, which is on the bottom of this slide. So another one of the recommendations from the Green Report was listed here at the top, which implored agencies to develop realistic cost projections for collections, maintenance, and operation. So this recommendation was deemed exceptionally important, such that it was included again in 2010, part of the America Competes Act legislation. So that stipulated that a common set of methodologies to be used by federal agencies for the assessment and projection of costs associated with the management and preservation of their scientific collections. So ultimately, it took a while to get a handle on how we would even go about it, given that scientific collections are funded in probably at least as many ways as there are member agencies in IWGSC, probably more. As a result, we finally got around to setting the goal to meet this mandate in mid-2018, and the goal was to have the report done by the end of this year. So we are really coming down to the wire. All right, so the economic study took a convening approach. David and other study participants scoured their networks for professionals who work in the economics field and might be able to shed light on common evaluation processes, if not methods that had previously been used on collections. So David convened 16 online meetings consisting of guest presentations and study group discussions. Those meetings engaged 35 collection specialists, economists, policy analysts, and budget professionals, many of whom were new to the IWGSC and to whom the IWGSC was previously unknown. The goal of the study was to encompass all federal collections, again from microbes to moon rocks, including collections that are institutional and both non-renewable and renewable. IWGSC considers institutional collections those that are preserved for future use. These are the collections that are formally accessioned under the care of a federal agency or their representative. So this busy figure, which is included in the report, shows a number of different types of collections and the processes that collect them or connect them. Most of us likely interact with the left panel, so these are the non-renewable collections, and they've been mentioned a bunch here today. So those are going to consist of objects from discrete times and places. You can think the museum collections, environmental survey collections, seed bank collections, those kinds of things. Renewable collections, depicted on the right panel, are those that can be constantly generated. So this would be something like a cultured collection of living plants used for developing better crop varieties. Project collections, which are in the middle of the non-renewable panel, are built, managed, and used for intramural use. So these are the collections some folks had mentioned about retiring and what do you do with those collections. Those project collections kind of fall under that category, where they're generally under the control of a researcher. So the project collections can be consumed through destructive analysis and may be discarded at the end of a project, or orphaned when you retire, that kind of thing. Institutional collections of both renewable and non-renewable varieties are shown along the top and governed by specific accessioning and deaccessioning policies and procedures. They are rarely consumed in their entirety, and their support and accessibility are considered over the long term. Okay, so on to the few things we can touch on from the report. Regarding operating costs, the IWGSC considers scientific collections as distributed research infrastructure made up of objects that have inherent value. Together, they constitute a marketplace with researchers and other investigators as their primary users. Given that they are federally supported, these collections, and thus their marketplace, are essentially not-for-profit. So for not-for-profit collections, costs can generally be thought of as the full operating costs minus cost recovery, if there is any, and then minus any benefits generated, again, if there are any. Other cost models for scientific collections do exist, an example being the American Type Culture Collection, which is an example of a privately owned and operated renewable collection. Their equation likely looks a little bit different than this. Yes, but as anybody who's worked on a personal budget can tell you, costs are the easy part, or at least the easy part to quantify. So what happens when you start thinking about benefits? So there are a variety of ways that businesses evaluate benefits, and the economic study goes into a few of them. I'll be using an example from the USGS to look at the value added by users. So this particular approach documents the benefits based on normal everyday activities. All right, so the Core Research Center of the USGS is an excellent example of the value added by users method. So CRC is proactive in promoting community use of the collection and has innovative practices that capture the results from that community use in ways that increase the value and future use of that collection. So USGS does not charge a fee for the use of these samples. However, users are required to provide both all the data derived from the analyses conducted on CRC samples and any duplicates of thin sections that were made from those core samples. So, thus, the CRC's costs include only the operational budget and then minus the benefits of the increased use and returned data and samples. As a result, the CRC has created a virtuous cycle. So like a company that reinvests profits in their research and development efforts in order to increase future productivity. This co-investment makes the collection more valuable due to increased discoverability, reliability, diversity, and volume of users. On top of that, USGS and CRC get additional services for free from the users. So this is going to include data curation, data analysis, and the resulting publications, and materials added back into the collection in the form of those duplicate thin sections, DNA extracts, or other things that are produced. So this led us to ask an additional question in that, are users willing to invest time and effort only in the most recently collected items of a collection, or do they think the entire collection is worthy of investment? And so to answer that, we looked at a little bit of data from the CRC. So in the top chart, the red bars are the age, or is the age distribution of the CRC cores. And in the bottom chart, the green bars indicate the number of requests for the CRC samples between 2016 and 2018. So as you can see, the distributions mirror each other pretty well, suggesting that requests by users support the idea that collections hold their value over time. All of that to say, the collections on the whole are worth preserving. All right, so that's about all I can say for now. We hope this short introduction to the report has piqued your interest. Again, feel free to contact me or David regarding this, and we do hope you'll see the full report by the end of the year. Thank you very much.
Thanks, Eileen. Does anyone have any questions or comments to Eileen or to the panel in general? Please.
Is this the panel questions?
Sure.
But if someone had a question for Eileen, they could go first.
I think it's you.
So my question is for mostly the entire panel. I think I've been working both with NSF-funded principal investigators and with federal employees on collections. With NSF-funded investigators, we think of incentives. There's carrot and stick methods for sample curation, and a funding agency like NASA or NSF has the ability to, if they wanted to, if the community wanted to, deny funding, for example, if you had curated your samples from a prior award. The situation is different for federal employees, and that's because the employers of NSF-funded PIs have really no control. Like a tenured faculty member cannot easily be disciplined, as you know. But federal workers, they can have it part of their performance plan. So I'm wondering, for especially the USGS members of the panel, to what extent is the USGS looking at making sample curation part of the performance plans of federal USGS employees to ensure that USGS samples become fair samples?
Excellent question. I'm just going to repeat it for people that might be listening online. The question was, to what extent is USGS including compliance to proper sample curation and management as part of performance plans for federal employees?
I could try to answer that, I think, as someone who supervises some federal employees who maintain collections. I think the trick is in, it's a very general performance issue. In other words, in a way, the scientist who chooses to do research that includes collecting samples and keeping them sort of brings on themselves that responsibility. It's essentially a basic conduct of science performance review activity. So it isn't as far as how well they maintain it, but as far as making it fair, making it actually interoperable, the context for performance would have to have included that from the beginning. In other words, what we're really mindful of in our policy is how do we make it easier for people to do it? I think more carrot than stick, maybe, because we don't start out, most of them didn't start out their study with an expectation of making interoperable data regarding their collections. So I think as soon as we have the tools for them, we can require it when they choose to do a study that is about collections. But it's such an individual thing that it will be hard. But I said that our policy was related to the open data policy. That's perfectly, because that standard is set across all types of data that are collected by USGS scientists with federal funds. That's much easier to discipline. And so probably this will be similar eventually in the collections arena. If federal funds were used to make samples and they are retained, you have to do it, period. So I think it's in the future, I guess, is the answer I'm coming to.
I would agree with that. I think we're just now, USGS has been really implementing efforts towards open data and open science over the last, I would say, 6 years or so. So now data management plans are required. The new quality management system activities related to producing quality data in laboratories across USGS, they're now being implemented through performance evaluations, and I suspect the collections will come on the tail of that. Marcia.
If I could just add something. I know your question was basically focused on federal employees, but I do think that more incentive could also be given within the university community, because when you think of it, most faculty reach their tenure and even promotion to full professor fairly early in their career. And there are not additional academic hurdles after that. And there can be faculty members who will then have 30 or more years of their career without an additional major hurdle that they have to surmount at their institution. So I had the privilege to participate in a workshop in Australia that was actually a wonderful research ecosystem to think about in terms of promoting open science practices, because of the fact that Australia plays on an international stage, but it is a small enough community that within a room that's a third the size of this room, you could have all of the provosts from all of the universities together in one place, and all of the leadership from all of the funding agencies, plus journal editors, all together, and agree on what would be good steps forward. And in one of the breakout tables that I was at, one idea that came forward was the idea of universities creating a promotional step beyond the full professor that might be a rotational chair that universities could offer that would be an added incentive, because this chair would be given to faculty that had been outstanding in open science and mentoring. And so they would recommend faculty who had been excellent in curating data, curating samples, and mentoring their students in those practices. And these faculty members would be given salary bumps, they would be given extra research awards or whatever to promote those practices. And it might be a rotating thing. They might have it for 5 years or something like that, and then it would be given to someone else. But basically, their students, their postdocs, other people in the university, when they look at who is being rewarded in this university, it would be those faculty members. And I thought that was a great idea.
Carol?
Please, go ahead.
I was just going to say, because I've worked in both, government agencies and academia. And I think the thing that got me in the government agencies is, yeah, there was a bit of sloppy behaviour, but we had an infrastructure. We had somewhere to store, and there were staff. If you wanted to do it, you could. What has just appalled me with this quick survey I did to do this talk, there's nothing in a couple of the universities. Like, they're putting shipping containers somewhere to store the rocks. There is no curator. And it reminds me of data in that I've also done both, and for a while we let the data slip, but we're able to retrieve it and we're doing really well. The thing that's appalling me with samples is there's no infrastructure, either physical or human, to start to rescue this. And that's what I'm trying to say. If you're sending people out to collect samples, particularly where they cost an arm and a leg to get to remote locations, then the funders have got to start saying somewhere we've got to put effort into infrastructure, both human and physical. And I think we need to start addressing that, because everyone who sent me those slides said, I want to do something, but I can't.
Two comments. First, Liz, thanks for that great question. And Marcia, that's a wonderful notion of creating a role that is in essence a sort of stewardship elder who promulgates great practice and is recognized for that. I think I'm going to appropriate that idea and try and share it onward. One of the things that I think would be important in this community is to share when things have been easy and successful. The 350,000 records that now have an IGSN number, that happened actually rather smoothly. So thank you, Kirsten. And thank you, NSF, for all the support work that created that. But that happened actually rather smoothly. And it can be challenging sometimes to contemplate the work to enhance records or to apply standards, whatever, in the collection stewardship realm. So it's important, when it works, it's important to share that good news. The second thing I wanted to touch on was maybe a point of philosophy, and I'm happy to be told I'm wrong. But sometimes when I think about collections, I think about the nature of all of us as scientists, that discovery is a fundamental part of what drives us. And discovery in the field can be a very compelling driver that maybe overwhelms sometimes the joy of discovery in a slag heap, in a warehouse, in a shipping container, in an organized collection. And so I don't know how we might go about stimulating that joy of discovery, of finding new information, new connections in existing collections, not just de novo in the field.
Thanks, Carol. Are there any more questions or comments from the audience? Please. So the question to the panel was that there are often, from funders, new money to go out and collect new specimens and create new collections, but not funds to actually digitize and preserve and properly curate existing collections, and have people on the panel encounter that as well.
Yes. I mean, I thank you, Rick, for that question. I think that's a common theme. I think in USGS, for instance, there are small mini grant programs called data rescue programs, but they're a great idea. But it's hard to prioritize them in the context of multiple policies. But what you're describing is accurate in my experience, both at USGS and elsewhere, that the digitization efforts, the things that happen after it's collected and preserved, are generally thought of as easy or cheap or free.
Volunteer-based.
I have the same challenges at the Natural History Museum, and I've been trying to put my money where my mouth is on the importance of FAIR by shifting the balance of my staff's work towards information and digital stewardship. That's a place where I can make a choice about resources. But it's easy to not remember the long life cycle of a digital record, and to not realize that digital records also need maintenance, just as physical objects need maintenance, and that you have to prepare for changing access systems, and realize that hopefully people will be wanting to enhance a record with additional information. So it's kind of a shift in thinking and in prioritization. And I guess I would say the way I try and work with it is to just realize that the reason why we have collections is so that they're used. And that is the fundamental reason why they're relevant, is that they're used. And that is part of our legacy and part of our responsibility as a national collection. So I have to adjust the way I work and the priorities that I establish so that we meet those accessibility aspirations.
I just wanted to add that great answer is that tension that we had with the USGS policy, is that we're not maintaining museum collections largely, and we're not collecting them precisely to enable others to do research. And so it's a tough one.
Whereas I would add, another major collection I did was over Northern Australia, where I must have collected about 1,000 granite samples. And someone wrote to me the other day and said, I don't have the energy to go and do that. Can I come and use your samples? And, that's the hidden advantage, that if you do get them properly digitised, known, you produce maps of where these samples are. Not the highly valuable fossils and that, but I think as we increase that knowledge, as travel costs, another thing that's cutting into it is occupational health and safety costs. That the properly maintained and well-managed collections then become an attraction.
Did you have a question or comment?
I just had a comment that I love hearing all of this. I come from the NASA Planetary Data System side of things. One of the things that I have heard is that is when individual researchers of an RNA grant are asked to write a data management plan. A lot of them are like, okay, I'm going to do this study, and they're asking for 3 years of funding. They put in 2 weeks of funding for their data management plan responsibility.
But
Great.
another important cost is, what is it going to cost to recollect? If you have something like that one I showed you.
Especially NASA.
Yeah, like you can't recollect the moon rocks. And that one I showed you, the 330,000 heavy mineral separates, you could not do that.
Yeah, I think the economic study is going to get at some of that, though there are many different use cases there. But that is something that USGS is trying to address in this working collections policy, asking scientists to really think about what's it going to take in the long term. If they're intending to keep these collections around, what's it going to take to properly maintain them and curate them and find a proper home for them? So you know.
One other idea, for example, NSF has the broader, what do they call it?
Impacts.
Broader impacts. I think that it would be fair if PIs started including under broader impacts for previous NSF grants that they've had and done a good job of curating their data, what the reuse of their information, their samples, their data has been. I know that, my own field was in marine geophysics and doing a lot of multi-channel seismic data. And under the broader impacts, because the repository always sent me an annual report on how many people had used my data sets again, under broader impacts, I would always list all of the publications that weren't by me that had used my data. And I felt that that was fair game.
Yeah, I think that's certainly an expected outcome of the USGS policy is to better be able to track samples and sample reuse, as well as the costs of actually maintaining samples that we're keeping as more institutional type collections.
Maybe, yeah, I just wanted to add to that. I mean, we have established, I think, an infrastructure that can create these statistics, these reuse information and so on through, the use of identifiers and linkages between the identifiers and so on. I see the challenge still in the uptake of all this. And I was wondering while we're sort of moving towards the end of the session, if there are ideas how we can take the next steps, what low-hanging fruits we have to actually increase the adoption of the procedures. One thing I see, we have a lot of registrations of IGSNs and so on, but they do not yet show up in the literature. And and the publishers haven't implemented the right changes in DOI metadata to include the IGSNs from a paper so that we can actually harvest that through machine reading and so on. There's a lot of things that need to move forward. And I heard the idea of, use cases, so to say, some projects, some very focused activities that could move this forward. So I would be really happy to hear some ideas. How can we take the next steps from now and drive that culture change, drive the the adoption of a new appreciation of samples forward?
I think the thing that got me, thank you for asking me to give a talk on rocks, haven't spoken about rocks for a long time. It was just the frustration of seeing so many pieces in place, but we're not connecting. And is it almost worth doing a end-to-end workflow of, someone gets a grant, they collect, that's published. Where are the weak spots? And I still say the two weakest spots to me are the repository, the physical repository to store it, but then the uptake of the modern techniques, which in turn are going to enhance the museum's visibility of you know, where their rocks were used. Like I say, it doesn't have to be in 1,000 publications. It was in the #1 paper from Nature, and it's the only time it's cited, and it's the Nobel Prize piece for science. And again, that's another thing we can do, but what is it we've got to do to change?
Oh, yeah, Liz.
Just in terms of ways forward, my observation as, you know, a lot of my job is I kind of an ambulance chaser. People get later in their careers, and, you know, we know the rocks are going to be valuable for the future. We know there's desire to work on the rocks. It is really hard to convince someone who is looking towards retirement in the next few years, and to convince them to spend a year organizing and culling their collection for preservation and future use,
Yep.
when their alternative is to spend that year either or emeritus faculty, for example, to spend that year getting out their papers. And I think it comes back to what Marcia said, the reward and the recognition is all about the papers you've published and not your infrastructure legacy. So to me, one low-hanging fruit, I think, would be to think of mechanisms for recognition of taking that time to turn your collections into legacy for the future, and not just, you know, a tick on your H index.
Although, for many years, Kirsten and I ran data rescue, and I can tell you the most prominent candidate that came up to rescue their data, and at times their samples, were emeritus people about to retire. That although they had their papers, they realised that their data and their samples would be in the next bin the minute they left the door. And they were knocking, remember I was sort of saying, oh my God, how many more, what's the polite word, senior citizens are going to be knocking on our door. It wasn't the younger people.
And I know that a lot of people start to get really panicked about, you know, my samples are going to be thrown out. But again, the problem is, and thank you. The problem that Leslie had brought up is the lack of infrastructure. So, you know, there is no place. I mean, there is the Smithsonian, but it's a big step, and it does require some, you know, resources as well. I'm always considering also opportunities to change the culture within the universities, because right now we've seen those pictures of bins and boxes in the basement and so on. If universities would start actually educating researchers and students to organize the samples in a different way, to at least keep the metadata records fine through registration and have specific places where these samples can go. The flow into the repositories or long-term archives like the Smithsonian may be much easier and not take a year or any amount of time to get it done.
Does the Smithsonian take samples from Australia?
Yes.
Yahoo!
You're going to get flooded.
The departments have a process for reviewing incoming accessions, but the basic answer is yes, yes.
But I think you're right, the fact that at the departmental level that they're not doing anything, even though in Australia we have that institutional guideline, means that generations are going through that don't care about samples. And it's so tragic when we seem to be getting a newer lot coming through that do. And yeah, they don't know where to start.
Can I just add to this?
Yeah.
One of these challenges for us, and I think it's probably true a lot of places, of course people want their legacy to last, and of course they want someone to rescue their collections. Their collections might not be worth it.
Yep.
But so until we start cataloging so that we can compare and assess, you might lose something without even asking, and you might spend a lot of time digitizing something that is of minimal value, and there's some subjectivity in that. But it's a critical component, so that's certainly what we've come across. We just can't make the right decisions unless we have a big picture on how to decide.
I've actually been approached within my institution to say, we have collections where we don't know what to do with it. What are the criteria for us to make a decision? And I think that is a really high priority and could be a low-hanging fruit in collecting policies and assessment methods from existing institutions that can help others. I think, though, we are out of time, and I encourage this discussion to go on after the meeting, if possible. I want to thank again all of our panelists for these fantastic contributions to a great session. So thank you, and enjoy the rest of the meeting.